Okay, today I'm going to talk to you about desalination. So, if a solution is said to be saline, it means it's salty. So what desalination means, it's just removing salt from water. So we might want to do this in order to create drinking water. So there's two main ways that we need to know about in terms of desalination. One is thermal desalination, and the other one is by a process we're going to learn about in a minute called reverse osmosis. So first of all, thermal desalination. Whenever we see the word thermal in science, we're thinking about heat. So the way that this works is a process we might have come across in chemistry called distillation. So we start off here with a mixture of salt and water, our saline solution. Remember, the whole thing that we're trying to achieve is we're trying to remove the salt and create drinking water, clean water. So what we can do is we can actually heat up this salty water. In the lab you can do it with a Bunsen burner, but in industry you might do it in a big boiler or furnace. But you actually, by heating the water, you cause this water here to evaporate. So by evaporating it, the salt does not evaporate and it stays here, but the water does evaporate, so it passes down here. So it turns from a liquid to a gas and turns down here. Now in the condenser, what happens is the steam actually condenses. So remember, this means turning from a gas back into a liquid. So the water can then drip down here. So what we've done is we've evaporated the water, leaving the salt behind. Then the steam, because this condenser is really nice and cool, it condenses and turns back from a gas into a liquid and goes in here. This is now clean drinking water that's safe to drink. Okay, the next process we're going to look at is reverse osmosis. So hopefully we already know a little bit about osmosis. So osmosis, remember, is the movement of water particles from a high concentration to a low concentration across a partially permeable membrane. So I'm just going to draw the setup right here. So the blue circles here, what they represent these are water molecules. So I've got two sides of my membrane. One, I have a high concentration of water molecules, and the other one, I have a lower concentration of water molecules, because these green circles represent salt molecules. So again, remember, desalination means removing salt from the water. I want to end up with just water and remove my salt. Now, in normal osmosis, the higher concentration of water is on this side. So in normal osmosis, we have a net movement from here to here, from a high concentration of water to a low concentration of water across a partially permeable membrane. But in reverse osmosis, as the name suggests, it's the other way. Now, the reason why water moves the other way is a lot of pressure is applied from this side right here. So there's pressure put on this side right here. Now, this causes, instead of in normal osmosis, where we go from a high concentration of water to a low concentration of water, we actually go the other way. So the water molecules actually move this way. Now, the reason why the salt does not cross and go that way is because the salt is too big to go through our partially permeable membrane. That's what partially permeable means. It means it only lets certain things through. So in this case, the water molecules move from this side to this side. So the salt, the stuff we don't want, is left behind. And on this side, all of this water can be taken off and removed for drinking water. So, just to summarise, desalination means removing salt from water. We can do this by thermal desalination, by evaporating the water and condensing it again to separate it from the salt, or by reverse osmosis, where we apply pressure which causes the water molecules to move against the concentration gradient from a low concentration of water to a high concentration of water to create clean drinking water. Thank you.